the MAP kinase pathway. When RAS exchanges its GDP for GTP, its affinity for RAF increases by 3 orders of magnitude. This interaction with RAS leads to RAF activation. Activated RAF activates MEK or MEK through phosphorylation. MEK or MEK is a serine, threonine, and tyrosine kinase that activates extracellular signal-regulated kinase 1 and 2, or better known as ERK1 and ERK2. Activated ERK1 and ERK2 then phosphorylate substrates that in turn regulate various cellular processes. So here we have a picture of this. We have RAS activating RAF. RAF activates MEK, and MEK activates ERK1 and 2, and then ERK1 and 2 will go on to phosphorylate downstream effector proteins. For MAP kinase module or pathway across many eukaryotic cells, the generic terms are RAS activates MAP kinase kinase kinase, MAP kinase 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 activates MAP kinase kinase, MAP kinase kinase will activate MAP kinase, and MAP kinase being the protein that goes on to phosphorylate different effector proteins. The RAF, MEK, ERK1 and 2 is what's seen in humans. Three proteins which are activated through transcription and translation, this is gene expression right here, by the MAP kinase pathway are Jun, FOS, and MYC. Jun and FOS form the transcription regulator AP1. If you remember from the first part of this section, that transcription regulators can be formed by dimerization. Jun and FOS are transcription regulators, and they will dimerize to form the transcription regulatory protein or transcription factor AP1. MYC is also a transcription regulator. These transcription regulators promote cell proliferation. FOS, Jun, and MYC are classified as immediate early genes, or IEGs. The product of expression of IEGs include transcription regulators such as MYC, FOS, and Jun. In turn, these transcription regulators, products of IEGs, will activate the transcription and translation of delayed immediate early genes. So before continuing, what we mean by the product of an IEG, immediate early gene, or immediate early genes. Remember, when we're saying immediate early genes, we're talking about genes. So the product of a gene is a protein. That's the product. The immediate early gene is nothing but a sequence of nucleotides in the chromosome. So here we have the activation of an RTK. And this leads to activation of downstream proteins and the RAS pathway, the MAP kinase pathway, for example. And one of the things that will get activated is a serine threonine kinase. For example, ERK1 and 2. And they will go ahead and activate pre-existing inactive transcription regulatory proteins, or transcription factors. So you have this activation. Here we have our activated transcription factors, or transcription regulatory proteins, and they go on to activate transcription of immediate early genes. And that leads to making the messenger RNA. The messenger RNA leaves the nucleus and you get translation. And among these immediate early genes are some more transcription regulatory proteins or transcription factors. And these transcription factors go into the nucleus again, and they activate the transcription of the delayed early genes. And you get your messenger RNA again for the delayed early genes, and then they go to the cytosol where they are translated into the products of these delayed early genes, the proteins. Now you can see that immediately after activation, after a short period of time, you're going to get your immediate early genes. Within the products of the immediate early genes, there are transcription regulators that will go on to activate the transcription of the delayed early genes. And after transcription, you get the messenger RNA, and then you get translation, so you get full expression of those delayed early genes, and you get their products. Among the delayed early genes are genes which push the cell through the cell cycle. The cell cycle includes the following phases. G1, a cell growth phase. S phase, a phase in which the chromosomes are duplicated. G2 is second cell growth phase. M phase where mitosis occurs, where you get 2 cells from 1. There is a restriction point, R point, within the cell cycle at late G1. If a cell has progressed past the R point, it will continue all the way through the cell cycle regardless of the availability of growth-promoting or inhibitory signals. In other words, cells are only responsive to growth-promoting and anti-proliferative signals in early G1. So what this picture is showing you is the cell cycle, and the cell cycle is moving like this. It is only during this period, starting at G1 all the way through to this restriction point, this R point, it's only during this period that growth-promoting or growth-inhibitory signals can be perceived by the cell. After the R point, the absence or the presence of any of these signals will have nothing to do with whether the cell will go all the way through mitosis. It will continue after this R point to go all the way through, divide, and come out of mitosis with 2 cells, even if the growth-promoting signals are removed or a lot of anti-proliferative signals are added. In this case, TGF-beta is an anti-proliferative signaling molecule. For a cell to get past the R point, the concentration and the activity of a single protein must increase. This protein is called cyclin D. The AP1 transcription regulator, a FOS-Jun dimer, promotes the expression of cyclin D. Thus, cyclin D is a delayed early gene, a DEG, and its expression, and thus activation, leads to a cell pushing past the R point in the cell cycle. So here we have a little bit more information on the pathway. Now, this part is just RAS activation. Okay, so we're not worried about that. RAS can be activated through multiple different pathways. This is showing 2. So we're going to ignore that and scroll up to RAS is activated. What happens next? And you have these different pathways, right? And you can see here is cyclin D1. Cyclin D1 is just the isoform of cyclin D within the cell. So we'll just call it cyclin D. Now here's AP1 right here. And AP1 is made from dimerization of FOS and Jun. Here's our MAP kinase pathway being activated, which eventually one of the things that happens leads to the transcription and translation of FOS. Remembering, FOS is an immediate early gene. And through the RAL pathway, which we're not interested in completely learning, but I just want to show that this is here, you have the transcription and translation of the Jun gene, and that is also an immediate early gene. And that leads to the making of the AP1 transcription regulator, and that leads to the transcription and translation of cyclin D1, and this is a delayed early gene. And once cyclin D1 levels go up, the cell will start to get past that R point, once there's sufficient amount of cyclin D1, or cyclin D. Note, activation of IEGs such as Jun and FOS, and delayed early genes such as cyclin D are examples of activation through increased cellular concentration. Jun, FOS, or MYC are commonly hyperactive in many cancers. If you are interested in how these things go awry in malignancies, I recommend taking cancer biology, which we cover all these topics and more. Okay, we'll stop here and continue later. Thank you.